Today we're going to talk a bit about measuring angles. And up until this point in your math career, you have been used to measuring angles using a unit of measurement called a degree. And a degree is simply 1 out of 360 parts of a circle. And that's based upon the knowledge that a circle is 360 degrees. Well, we've gotten used to using this kind of measurement. We have learned, for example, that a straight angle, which is 1/2 of a circle, is equal to 180 degrees. And we've learned other terms in angle measurements like right angles, which are equal to 90 degrees. We've come up with other vocabulary. Acute angles are all of those angles that are less than 90 degrees. Obtuse angles are those angles that are greater than 90 degrees. And we've been using this system for quite a while, so we've gotten pretty comfortable with it. But one question that sometimes arises is, where did 360 degrees come from? Why is a circle 360? Why isn't it 200 degrees or 512 degrees? The answer is, we're not really sure. At one point, someone decided to make a circle 360, and we've just gotten really used to using that number. It could have been a different number, though, and the system would have worked in a similar way. The next question that might arise is, well, is this the best way to measure angles? And the answer to that is maybe not. So today we're going to look at a new way of measuring angles, a way that is very useful when working with circles, and particularly when talking about the lengths of arcs. That thing's going to be called a radian. So this is our new unit of measurement, and I'm going to try and define it for you here. So I have 3 circles here. Notice the first one, I have circle A that has a radius of length r. Now let's imagine that I make this angle exactly big enough such that arc BC is also equal to a length of r. And notice in my other 2 circles, this is exactly true. A radius of 2, and we've made the angle exactly big enough such that the arc also has a length of 2. Or a radius of 5, and an arc that is 5. Now this angle I'm going to decide is a special angle. And it is special because it is an angle that makes an arc that has a radius as its length. And I'm going to call the measurement of this angle 1 radian. And that would mean these other 2 angles are 1 radian as well. And that allows us to create a definition for this new word radian. A radian, it is a unit of measurement, specifically a unit of measuring angles. And it is a measurement that produces an angle. Radian is equal to an angle that intersects an arc whose length is equal to the radius of the circle. Let's see how that looks in a couple of problems and see if it can start to make a little bit more sense. How many radians is angle A? Well, we've got a circle with a radius of 3, and it produces an arc length that is twice as long as the radius. Well, we just defined above that 1 radian will always produce an arc that is equal to the radius. So in our case, that arc would be equal to 3 if the angle was 1 radian. But in our problem, the arc is actually equal to 6, which is twice as much as 3, which means that the angle is going to have to be 2 radians. Twice as many radians produce an arc that is twice as long. Let's look at the second problem. Angle A is 3 radians. How long is BC? Well, we have a radius that is equal to 10. And we know that if it was 1 radian, that would produce an arc that is equal to 10. However, we've got an angle that is 3 radians. That is 3 times as many radians. That means it's going to produce an arc that is 3 times as long, or an arc that has a length of 30. Next question that we might ask ourselves is, well, how many radians would it take to produce a semicircle? Again, we want to remind ourselves that 1 radian will produce an arc that is equal to the radius. We've got a circle that has a radius of r, and we're asking ourselves, well, how many radians would it take to produce BC? Well, it would be useful to know how long BC is if we want to know how many radians it is. And we can calculate that. BC is a semicircle, so it's based on the circumference, and we know that circumference is calculated as 2 pi times radius. And a semicircle being half of that is going to give us pi times radius. So instead of having an arc that is equal to the radius, we have an arc that is equal to pi times the radius. And in order to produce an arc that is pi times the radius, we are going to need pi radians. This is a very, very useful piece of information because now we know the relationship between radians and degrees. The reason we know that is we know how many degrees a semicircle is. A semicircle is 180 degrees. And 180 degrees is the same degree measure as pi radians is a radian measure. Those two things represent the same angle, just using different units of measurement. This one uses degrees to measure, this one uses radians to measure. And this is a useful relationship because it's going to allow us to change back and forth between degrees and radians. Because 180 degrees equals pi radians, I now know a couple of relationships. For example, I now know that 180 divided by pi degrees is going to produce 1 radian. We just divided both sides by pi. Likewise, I know that 1 degree is going to be the same as pi over 180 radians. These two values become ways for us to convert back and forth between radians and degrees. So let's try a couple of examples. First problem is we want to convert each angle from degrees to radians. So I have an angle that is 60 degrees. I also know from our relationship above that 1 degree is equal to pi over 180 radians. So that means every one of these degrees is pi over 180, or pi over 180 radians per degree. If we multiply these two values, the degrees will cancel out, and we will get 60 pi over 180. And we want to simplify that as well. 60 divided by 180 is 1 divided by 3. And so we are left with 1 pi over 3 radians. Try example number 2 in the same way and see how it goes. Problem number 2, we're given an angle of 270 degrees. Let me write it as degrees. We can convert from degrees to radians because pi radians is the same as 180 degrees. And multiplying these two things together gives us 270 pi over 180, or we can simplify these, both divisible by 10, and these are both divisible by 9, 3 pi over 2 radians. You could also write that as 3/2 pi radians. Let's try and go the other direction as well. So this time we want to convert from radians to degrees. So we are given an angle measurement, angle A, of 2 pi over 3 radians. Since we're converting the other way, we need to use our other conversion factor, and that is that 1 radian is equal to 180 over pi degrees. So if we multiply by 180 over pi, and again this represents the number of degrees per radian, then that is going to calculate this angle measurement in degrees. The radian will cancel out. The pi's also divide to 1. And we are left with 2 times 180 over 3. And 180 divided by 3, that's just 60. So we are left with 120 degrees. Try the second one on your own. Come back and see how you did. Now that you've had a second to pause and try the second one, we've got an angle of 7 pi over 6 radians. We will multiply by our conversion factor of 180 degrees per pi radians. When we multiply, we know that our pi's are going to cancel out, our radians are going to cancel out. We can also go ahead and simplify the 6 and the 180, that is 30. And we are left with 7 times 30, which is 210 degrees.